Hey team, we're back here to talk about the coordinate plane, what we did yesterday, and some of the things that we did yesterday was just basically getting to know it. We know that we have our y-axis right here, we're up and down, riding up and down is our y-axis. If you're not sure about that, or that's something that's still not clear to you, make sure we get it down in a notebook, and our x-axis, which runs the horizontal. We also know that every ordered pair is named as parentheses and then x comma y. So if we look at our red, take a second, what would be the coordinates of the red dot? Well, on the x, I'm going to go -2, but I'm not going to go up or down at all. So -2, 0. And there it is right here on the red. And my blue is I'm going to look and I have to go 2 on the right. So I'm going to go 2 along the x. That's +2. But then I have to go down 2. And so my point's going to be 2, -2. So today we kind of spent our time with that yesterday. Today, what we're going to do is talk about how we can create shapes from this. So let's start with the idea of creating a rectangle. If I'm given these two vertices here, right, these 2 points, and I want them to be corners of my rectangle, well, what would be the other two coordinates? And so, well, one of the things that I know about a rectangle is that it is that opposite sides are both parallel and congruent. So I want the ones that are across from each other to be parallel and congruent. And so if you look at that, it seems pretty easy to create that rectangle by saying, well, I think I have a point here and a point here. So my other 2 points to create that rectangle are going to be right here and right here. So those 2 points I'm going to put in there. So the first one right here would be 2, and I'm not going to go up or down at all. So it's going to be 2, 0. 2, comma, 0. I'm going to close that, and there's my green dot right there. There it is. And then I'm going to close that off with my next one would have to be -2 and then down 2. So -2, -2. So I'm going to put my -2, comma, -2 and close that one up. And there's my purple. And there you go. And I have my rectangle right there. There's my rectangle. So that was easy, right? It's pretty easy. If I know that I have these two diagonals, it's pretty easy to estimate where these had to be, the green and the purple, to create that. I'm going to get rid of them because what if I wanted to create a square? Well, if I go along the y right here and here, that creates a rectangle, but not a square. I want it to be, I know a square has to have right angles, and I know it has to be congruent sides as well. So I can't go up and down. There's no way to do that. So now I'm thinking I have to have something that looks like that. That would be the only way to do that. So how do I get there? Well, if we remember, that's a slope, right? That's our slope, is our rise and run. Rise 1, 2, 3, 4, -4, and then 1, 2, 3, 4, 5, 6, 7, 8, 4, 8, -4, +8 would put me here. So shouldn't I be able to do that to create another point if I'm going to keep a parallel line? I want to keep that same that same slope. So I'm going to this time I'm going to go. Let's try this. If I go up 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, and put a point there, that would be 0, 4. Let's check this out. 0, comma, 4. And I'm going to close that out. Does that do it? I don't know. Let's try. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. There's my next point, which would be 4, 2. Let's put that one in. 4, comma, 2. Look what I have. Well, let's see if the slopes. So one way to find out if these are parallel is to check the slope again. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4. So this one here has to be parallel to this one here. Let's try it. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Well, I know that that's parallel. So these two lines are definitely parallel. Let's find out about these ones. I'm going to go left. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. These are also parallel. So are they also congruent? Well, how can we test that? Well, we can kind of ballpark it. We can say, well, those points are 1, 2, 1, right? That would be across those two. 1, 2, 1 across two more. 1, 2, 1 across two more. 1, 2, 1 across two more. Let's try this one. 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2, 1. So it's crossing all of the same number of squares. And so while I can't prove it, they seem to be the same. Let's try again. 1, 2, 1, 1, 2. Wait a second. Can't I just go 8 and 4? If it's going 8 and 4, then doesn't that have to be the same? And if this is also going 8 and 4, doesn't this have to be the same? Yeah, I got a square. I just created a square. Absolutely, that's a square. By using the slope, I was able to count off the next pieces, and I've got myself a square. Hmm. All right, that's kind of cool. So let's play around with that today. In today's investigation, you'll play around with those things. A lot of this has to do with kind of getting your head around it. So you will play with it and realize that the slope is a tool that we can use to find our next points. So go ahead and play with that. Try it out in the investigation and in your collaboration. Go ahead and talk about it. And ultimately, I'm here if you need any help. So good luck with that. Get started and have a great day.